Hi everyone, welcome to this video on lesson 17 of Earth and Climate. This is about the greenhouse effect. So finally, we've been kind of building up to this for a whole series of lessons now, I think 7 or 8 lessons. And we're finally bringing students to this really important concept that they will no doubt have heard of because it's been covered in primary school and many of them will have come across ideas around greenhouse effect and global warming in the media. And now we're going to give them a really explicit picture about exactly what it is that's going on and how this relates to the choices that they make, both personally and politically and so on. And I think that second part is really important. It's not just an abstract model of what's going on. What they need is to see how this relates to them and their choices. And this is why throughout this scheme of work, we've been coming back again and again and again to our picture of the carbon cycle. And what we want to emphasize is there is this interaction between what's going on at the surface of the Earth and what's going on in the Earth's atmosphere. This has been the whole story of this sequence of lessons. And what we want them to recognize is that our actions, especially around burning fossil fuels and energy consumption and all of the different things that we do that contribute to that, our actions have had a profound impact on what's happening in the sky, in the atmosphere above us. And that's why in this lesson, I think it's worthwhile starting with a couple of graphs to show what's happened in terms of population, in terms of energy consumption, and also what's happened in terms of carbon dioxide. And depending on your group, you may wish to go into how we tend to measure carbon dioxide concentration in the atmosphere, and the kind of drilling down into the ice cores and looking at different levels of carbon dioxide over time. And using the ice as a kind of a bit like counting the rings in a tree, I suppose. But if not, you can just sort of tell them that actually, well, look, because we're using more cars and burning more fuel for electricity and so on, there's lots and lots more carbon dioxide in the atmosphere. And what we're going to do then is say, well, okay, why does that make a difference? That's something relatively concrete. We drive our cars more. And we've got banks of servers that are using loads and loads of electricity because we've all moved online. But why does that make any difference? So what we want to do is explain the greenhouse effect here. And the first thing to emphasize to students is the greenhouse effect is not a bad thing. The greenhouse effect, in fact, is the only reason that life is possible on our planet. So I think it's worth starting with a comparison between the case where you had no atmosphere and the case where you have what I'm calling the current atmosphere. And what we're going to do, and I'm going to use a red pen for this because we're talking about infrared, we're going to talk about the sun and how the sun emits light of all different frequencies, or I should say electromagnetic radiation of all different frequencies. We obviously experience primarily, the most obvious one is the visible light that we can see. But another obvious one is the infrared that warms our skin on a hot day. So we can show the infrared coming from the sun to the Earth. And we can say what happens is when infrared light, and I'll label this as infrared to students so that they're really clear what it is that I'm talking about. When infrared radiation arrives from the sun to the Earth's surface, some of that infrared is absorbed, so you could show absorption here, and if you wanted you could label that. It really is up to you, but a good deal of it is reflected. Now if there was no atmosphere, yes, it would heat up the Earth a little bit. It would heat up the Earth a little bit because some is absorbed, but the fact that quite a lot of it is reflected means that actually the Earth would be a pretty cold place. And we're talking, I mean, you can ask students this, and it's a good opportunity to reinforce some of the stuff they did about temperature all the way back in year 7. But actually a lot of space is kind of single-digit numbers of kelvins, so pretty close to absolute zero. And actually the Earth would be somewhere similar there, where even kind of the most basic gases like oxygen and nitrogen would be frozen. So the point being, life as we know it, we're warm-blooded creatures who rely on plants growing and all of that sort of stuff, would be completely impossible. So maybe we could make a note here to students and just say something along the lines of, if there was no atmosphere, the Earth would be too cold for life. Certainly life as we know it. So that's the first thing that we can say. And what we want to do then is compare that to the current situation. So what we actually know is that we have an atmosphere. So the first thing I'm going to do is just do in a kind of, I tend to do atmospheres almost like a cloud, so as a kind of not quite a smooth circle, just to show that this is essentially a kind of ball of gas surrounding the Earth. And what I can do is talk to students, and again, this is where you could do some cold calling or whiteboard questioning to ask how that atmosphere is composed. This is what they learned in the last lesson. And what they should remember is that it's mostly nitrogen. There's also about 20% of it is oxygen. And then a very tiny amount of it is made up of carbon dioxide and other greenhouse gases. And this is where we're going to introduce that term greenhouse gases. So I'm just going to label this here to say the current atmosphere is, I'll put small amount of greenhouse gases. And then it'll be worth me mentioning some of those greenhouse gases to students. So it's not just carbon dioxide, it's also methane, water vapor, a few others that I can't remember off the top of my head, but they're in the slides. But there's other greenhouse gases there, and again, depending on your group, you may wish to write that down so that they've got that there. But that's going to be a question in the practice questions later. So you may also wish to just tell them and then see whether they can remember that, because that act of retrieving, we hope, helps them build those memories. But what we want to show next is, okay, if you've got an atmosphere with a small amount of greenhouse gases, then what happens is this. So as the infrared radiation arrives from the sun, now some of it would actually be reflected here, but I don't want to overcomplicate my diagram, so I'm just going to kind of carry on straight through. What happens is exactly the same as before, is that lots of that infrared radiation reaches the Earth. Some of it is absorbed. Again, I don't know what a better way of showing absorption is here, but I'm going to say some of it is absorbed, and quite a bit of it is reflected. I'm going to show it being reflected here like this. But then what happens is when it reaches the kind of edge of the atmosphere again, or actually anywhere in the atmosphere, is that if there's some greenhouse gases there, some of that can be reflected back. So some of it can be reflected back, some of it will just pass straight through and carry on like this. But because some of it is reflected back and then reflects again, and I should say a bit more is absorbed by the Earth, so let's do that here. But then it reflects back, so I'll try and get my angles of incidence and reflection equal, so it comes back like this, but then some of it will be reflected back again, and so on. And what we start to see is this pattern whereby actually a lot more of that infrared radiation is absorbed by the surface of the Earth. So the Earth becomes a much warmer place, and this is what is so important about having an atmosphere with some greenhouse gases in, is that it allows the planet to be warm enough for life. So I might just add a note here saying planet warm enough for life. But so that's really good, and this is where we're at the moment. We're in this kind of sweet spot where the planet is at the perfect temperature to sustain this rich diversity of life that is all around us. But what we want to do then is say, well, okay, there's this future atmosphere, and we're kind of on this trajectory already. So if I draw my atmosphere again, like this, looks a bit like a fried egg at the moment, but hopefully students kind of get what you're referring to here. Now, if we were to have an atmosphere as follows, and I might try and shade this a bit darker, I don't know whether that's helpful, but just some way of showing that this is an atmosphere with even more greenhouse gases. And again, this is where you might wish to go back to your diagram of the carbon cycle and say, what's happening here at the moment is that because of all this stuff that's going on here, and also as we'll see later this lesson a little bit, and certainly in the next lesson, because we're cutting down lots of trees as well and putting more animals in place. But all of these things are contributing to there being more carbon dioxide and indeed other greenhouse gases in the atmosphere. So what we want to do is say, well, in the future then we might have this atmosphere where it's not just a small amount, let's put more greenhouse gases. And again, it's worth mentioning to students, we're not going to get to the stage where we're like Venus and our atmosphere is mostly carbon dioxide. That's not going to happen anytime soon, and because therefore the temperature would be way too hot for any life. We're not talking about anything too crazy, but essentially what we're saying is, if there's more greenhouse gases, pardon me, if there's more greenhouse gases, then we get the same process here. So infrared radiation comes in, some of it is absorbed, and then the point is, and again, I'm not sure how exactly you want to represent this, but the point is, less gets out. So I might draw a kind of fainter line here like that. Less escapes again, more is reflected back. So I might put here something along the lines of more is reflected back and more heat is absorbed. And again, I'm drawing a diagram here, but I'm also commentating while I'm talking. I'm explaining this to students. If you wanted, you could do a thicker line, maybe something like that. But you want to get that idea across that more is reflected, less passes back out of the atmosphere after it's reflected the first time. So then we can say, okay, this reflects again. So we'll draw a line out here. And then, again, not much or less passes out of the atmosphere, but quite a bit goes back to the Earth. And then we can show that here. So again, you might wish to add a note here saying more infrared absorbed. And then the main point that we want to emphasize is, if there's more greenhouse gases, well, maybe I'll do this in red as well. I'll put temperature, because more infrared is absorbed, temperature of planet increases. And that's the greenhouse effect. Now, it's worth coming back to the concrete here and talking about why this matters. And again, I'm not sure diagrams under the visualizer are the best way. I think diagrams under the visualizer are great for illustrating the difference between no atmosphere, the current atmosphere, and one with more greenhouse gases. But we need to then make that human, students, or not necessarily human, but we need to kind of say how that relates to the world that's a bit closer, a bit more concrete, and a bit closer to what they experience. So this is where we can talk about, well, okay, what happens if the temperature of the planet increases? The polar ice caps melt, sea waters increase, we get these more extreme weather events. We might get raised sea level and whole countries or certainly whole cities being flooded. So we can talk to students about some of these really, really big ideas. And once they've got this mental model of why it is that the temperature of the planet is increasing, then we can go and relate that to the things that they'll already be a bit more familiar with, and they'll have a clearer picture of why that happens. So really, all we want them to be able to do in this lesson, I mean, I think it's worth drawing the first one that I did here, because that shows that the greenhouse effect is not a bad thing. That would be a terrible misconception. The greenhouse effect is necessary to life as we know it. But what we really want them to take away is this part of the diagram here, the difference between the current atmosphere and the future atmosphere, and why, if there's more greenhouse gases in the atmosphere, less of the infrared radiation can escape back out of the atmosphere, more is reflected back to the Earth, therefore more is absorbed, and the temperature of the planet increases. And that's what we want them to write about in the independent practice at the end of this lesson. What we'll do in the next lesson is relate this picture that we've introduced today back to the carbon cycle and start thinking, okay, if we know that there's this link between more greenhouse gases in the atmosphere and the temperature of the planet increasing, let's now change some of the terms in here. Let's imagine there's more cars or fewer cars. Let's imagine there's fewer trees and more animals and so on, and start thinking about the effects that would have on the rate of climate change in terms of the greenhouse effect. And then we will have nearly finished this sequence of works, this sequence of lessons, and we hope students will have a really good working model of exactly what it is that's going on.